Okay, so for real zeros of polynomial functions, we're first going to talk about the remainder theorem. And the remainder theorem says if a polynomial p of x is divided by the binomial x minus a, then the remainder is going to equal p of a. And for this first example, we're going to be given a polynomial p of x equals 4x to the fifth minus 3x to the fourth plus 2x to the third minus 7x squared plus 9x minus 5. And we're going to find p of a. We're going to do this two ways. The first way is what you would normally do when you're finding p of 2 or f of something, f of a number. You're going to plug that number in for x. So I have 4 times 2 raised to the fifth, 3 times 2 raised to the fourth, plus 2 times 2 raised to the third, minus 7 times 2 squared, plus 9 times 2 minus 5. And then to simplify, 4 times 32 minus 3 times 16 plus 2 times 8 minus 7 times 4 plus 18 minus 5. This becomes 128 minus 48 plus 16 minus 28 plus 18 minus 5, and if you simplify all that you get 81. Okay, and what the remainder theorem says is that I can do the same problem using synthetic division. So this is my polynomial that I'm going to be dividing into, and I'm going to be dividing it by x minus a, which in this case is x minus 2, which means I have 2 up here. And notice that this is the same as this one, okay, because what you put in that spot for synthetic division is the x value. So I have 4, negative 3, 2, negative 7, 9, negative 5. Remember to check to see if anything is missing. I don't have any missing terms here. My 4 comes down, multiply with 2, I get 8, positive 5, 10, 12, multiply with 2, 24, 14, 34, 43, 86, and then 81. And what it says is that p of 2 is equal to the remainder, which is 81. And that's what we just did. Okay, the factor theorem says that if p of a is equal to 0, then x minus a is a factor of p of x. And conversely, if it goes the other way as well, if x minus a is a factor of p of x, then p of a is equal to 0. So determine if x plus 2 is a factor of this polynomial p of x. We're going to use synthetic division, and what's going to go on my top left is going to be negative 2 in this case, because I have to divide this polynomial p of x by x plus 2, which means I'm going to use negative 2 in that spot. So my coefficients, there's no missing terms, so I don't need to worry about the zeros. I have 1, negative 2, negative 5, and positive 6. Bring the 1 down, multiply with negative 2, negative 4, combine them, multiply with negative 2, negative 6, combine them, I'm sorry, let me fix that. It shouldn't be negative 6, that's going to be positive 8. I'm multiplying those two, negative 4 times negative 2, that's going to be positive 8. Combine positive 8 and negative 5, that's going to be positive 3, negative 6, and 0. Now because this remainder ended up being 0, that means x plus 2 is a factor and the directions will also say if it is, then completely factor. So to completely factor, I'm going to take the quadratic that's left, x squared minus 4x plus 3, and I'm going to factor that, and what that factors into is x minus 3 times x minus 1. I'm going to include the x plus 2 that was originally factored, and this is the factored form. X plus 2 is a factor, and this is completely factored down here. Okay, I need to determine if x minus 3 and x plus 2 are factors, and if they are, I need to completely factor them. Well, I'm going to use synthetic division. Doesn't matter which one you use first. I'm first going to go with 3 here. And my coefficients, this one, there are missing terms, so I have a 1, and then the x cubed term is missing. My x squared term is negative 13. My x term is missing, and my constant is 36. So I'm going to bring this 1 down, multiply it with 3, add, multiply with 3, add, multiply with 3, add, multiply with 3, and they combine to be 0, which means because the remainder is 0, x minus 3 is a factor. So what I'm going to do is I'm going to use divide by x plus 2, which means I'm going to use negative 2 in the synthetic division. But instead of doing it from this quartic, I'm going to use my new cubic that I got from the last synthetic division. So I have 1, positive 3, negative 4, negative 12, and there aren't any missing terms in that one. So I'm going to bring my 1 down, multiply with negative 2, add, that becomes positive 1, multiply with negative 2, add, that becomes negative 6, multiply with negative 2, that becomes positive 12, and they add up to 0, which means that x plus 2 is a factor as well. And then to completely factor it, I'm left with x squared plus x minus 6, which that factors into x plus 3 times x minus 2, and then I'm going to include the other two factors, x minus 3 and x plus 2. This is completely factored.